Hi everyone, so you're at the command line workshop. My name's Michael, it's a pleasure to have you all. We're going to be covering just generally how to use the command line. I'm sure, just to go around quickly, what are your all's experiences with the command line? Do you have, just to get a general sense?
None.
None? Okay.
I'm really bad at it.
Okay, awesome. Okay, well that's cool. So this is actually the perfect workshop then, because we're going to try to kind of get you all familiar with it and just a bit more acquainted with it. It's more just to help, get a sense of what you can do and just generally getting over some of the things that may seem a bit unfamiliar to you. But before we start, I'd like to give like a bit of a background. So my name's Michael, and so I'm first year at SLIS. Before doing this, I was a systems administrator, so I worked there for 3 years, and so that's how I have a lot of experience with this. In high school and college, I tinkered a lot with Linux, and slowly through that tinkering, it's kind of turned into something that was kind of a profession that I'm still doing with the tech lab now, and also trying to bring that into SLIS as well. So first up, before we start getting into the shell aspect of it, so there's a question of like, why are we doing this, right? Because it seems like, you're used to having like a graphical program of some sort. This looks very forbidding. Some reasons why. So first off, it used to be, in the old days, you had like a typewriter. It was like literally just like an automated typewriter that would basically type out the output from the text. So the fact that you have like a screen here that has like colors and dynamically refreshes is actually a relatively recent thing. So it used to be that when in the 70s or something like that, what you see here was actually like kind of printed out on a teletype. And I can bring that up actually right now to show you all. These machines are actually really cool, and they're just really kind of like an offshoot of what used to be just like regular typewriters, but they basically made them automated, and so that the computer would actually do the type out for you. So you notice here that it's doing the login screen, and so these characters would actually get automatically typed on a sheet of paper. And this is just the machine doing that for you. And you'll notice here, it's going to start looking familiar where you have those like console lines. And so that's actually used to be how you would interact with the computer, is that you would literally be typing at a typewriter trying to type in commands, and you would click it and you press enter, and then like this would just start kind of printing the output on the screen for you. And so before that, of course, if you all remember, there were like punch cards that you used to use, but that was from an earlier time. But in terms of the design of like what you're seeing on the console, this is kind of what the historical background behind that was. And these are just, so you notice here, if I like, hey, if we like pause like here, you'll notice that you have kind of this here where it's like you have a bunch of like fixed columns. So that actually corresponds with what you see here, is that if I were to press list, it's almost like you would have a teletypewriter basically typing out each letter as you go, as the page kind of scrolls down. So, in other words, the interface has kind of been around for a long time, and this historically was kind of just a descendant of a lot of the early teletypes. It's also, a lot of the times you'll have a lot of programs, especially for more scientific and computing stuff, will still actually use this interface a lot. Just because it's easier and it's more standardized than like creating like a GUI of some sort. As opposed to like creating like an app, a lot of stuff that you'll use will actually just be like a command line application that your you're using this interface with. And finally, the other thing that we'll get into is that it's also, because this is so standardized, essentially still it's just like a wall. It's just like a text interface. It's actually a lot easier to write programs that like cooperate with each other. And so we'll get into, when we get into piping, that this kind of sparseness and austerity is actually useful if you want to make programs work with each other, because there's less difference, or kind of, there are fewer concerns with like interoperability when you're dealing with the text interface as opposed to when you're dealing with applications. So before I continue, do we have any questions so far? Anything that you're curious about? It's mostly just cursory stuff for now, but cool. All right. So before we continue, I want to bring up this funny little video that was actually one of the original videos for Unix. And so this is actually, this person you see here is Kernighan, who was kind of very associated with the creation of Unix, and also co-wrote a very influential textbook on C, which is a programming language that's often associated with Unix.
Obstacles to be overcome. When Ken Thompson and Dennis Ritchie started building the Unix system in 1969, they found a structure which simplified many aspects of the interactions between computers and people. Thompson and Ritchie were aiming to keep their system simple, and they found a collection of primitives that enabled them to do a great deal with a very few primitives.
The Unix system is made up sort of three layers, if you like. The central layer, the kernel, is the thing that controls the resources of the machine. Then wrapped around that, at least conceptually, is something called a shell, which is the interface between most users and the kernel part. It sits there and waits for you to type commands at it and then it interprets them. And then around that, sort of yet another layer, are useful programs, things like editors and compilers for programming languages and document formatting programs, and programs that you write yourself. And what you can do is to think of the Unix system programs, basically, as in some sense the building blocks with which you can create things. And the thing that distinguishes the Unix system from many other systems is the degree to which those building blocks can be glued together in a variety of different ways, not just obvious ways, but in many cases very unobvious ways, to get different jobs done. The system is very flexible in that respect. I think the notion of pipelining is the fundamental contribution of the system. You can take a bunch of programs, two or more programs, and stick them together end to end so that the data simply flows from the one on the left to the one on the right. And the system itself looks after all the connections, all of the synchronization, making sure that the data goes from the one into the other. The programs themselves don't know anything about the connection. As far as they're concerned, they're just talking to the terminal. And let me give you an example of how this works in practice. The system, as I mentioned, is used a lot for document preparation kinds of things. Programs for helping you type letters or produce technical papers or write books. In all of those things, of course, people, when they're typing into the machine, make spelling mistakes. So let's see how we could use some of these building block notions in practice to help you develop a program for finding spelling mistakes. Suppose I take a sentence. This is a sentence which is in a paper that John Massey and I wrote some years ago now. If you look at it carefully, you'll see that there are actually a couple of spelling mistakes in there. Now, suppose that we wanted to find the spelling mistakes using a machine. How would we do that? Well, basically what we would do, the simplest thing I can think of, is to split the sentence there into words, individual words, and then compare the words against the dictionary. And every time we find a word which is in that sentence but not in the dictionary, it's at least a plausible contender for being a spelling mistake. Now, how do we do that? What I want to show is that you can do that using just existing Unix programs, just gluing them together to get the job done. Suppose that we say, first we'll take a program called MakeWords, and we'll run that on the sentence. And what that does is break the thing up into one word per line. Now I'll take the output and I'll pipe it into another program which will simply convert it into lowercase. The reason I want to convert it into lowercase is that my dictionary doesn't have any capitalizations. And so words like bell and Unix, which are capitalized here, would show up as spelling mistakes unless I did this. Now, the next thing that I want to do, my dictionary is in fact sorted in alphabetical order, dictionaries are. And so it's a lot easier for me to compare the words of my document to the words in the dictionary if they're sorted. So I'm going to run them in sort. And finally, if you look at it carefully, it doesn't show up very easily here, but there are, in fact, there is a duplicate word there. System appears twice. And in a real document, words like THE would show up many times. So we'd like to get rid of duplicates. So let's throw that through another program called Unique. So what we've got so far is we've got the words of my document, in this case the sentence, one word per line, in lowercase, neatly sorted, and all of the duplicate words thrown away. So there's only one word, one instance of each different word. And then what I'm going to do is run it into one last program called Mismatch, which will simply print all of the words that came down this pipeline and print out the ones that were in the document that were in the dictionary. What we have here is 5 separate programs cooperating to do this job, and in one giant pipeline. Now, if you look at the list that came out, you'll see that indeed we got laboratories and provide, which were actually spelling mistakes. But of course, we've got 2 other words as well, and this tells you not only what's good about these words, but also what's bad about it. Time sharing is not a spelling mistake, but it's a perfectly fine example of technical jargon, the sort of thing that means something to everybody in the computer business, means nothing whatsoever to people who are not computer scientists. And the word Unix is a fine example of something that's not going to be found in the normal dictionary. So, what do? First, we take the misspelled words and we go back to the original document and we correct it so we don't have any spelling mistakes. Secondly, we take the words that, like time sharing in Unix, that are not spelling mistakes but which showed up here, and we put them back into our dictionary so that the next time somebody has a document that contains Unix or time sharing, they don't show up as spelling mistakes. So we've not only done our own job, but we've improved the tool that we're using in the process. You notice that I did that whole job without writing any programs at all. The whole thing is cobbled together out of programs that already exist. And all I did was to use the fact that the system provides this mechanism of the pipeline so that I can take programs and stick them together one after another to get my job done. And I think this is one of the reasons why the system's so productive, that there's a large collection of things that people have already built that we use, and as we build our new things, then they become part of the repertoire of things that people subsequently can build on. During the last decade.
Cool. So that's kind of a rough thing. Of course, this hasn't aged as well. You'll notice even from like suits, the attire, of computers and all of that. But the general principles kind of stayed the same, where the idea was to basically make it so-called easy to use. And it's funny and ironic now because we look at something like this and it seems very uneasy to use just because the environment has kind of changed in terms of how we do computing. And so in terms of trying to make it easier to use or more accessible, I was going to just run through a couple exercises here. And so just to orient you with the shell, you see here at the first is, you'll notice this, right? And so have you all seen something like this before? Yeah, and so you're all familiar with, typing in a command, you press enter and it runs, right? And okay, well, we'll get to that. So the idea is here, you have this interface, right? It looks like a terminal. There's really all just like a bunch of white space. But what you'll notice at the top is that you have what's called a prompt. And so you see that kind of series of letters there. You see that colon, and you see that squiggly line, and then you see run 8, and then the $sign and a space. And then you notice that you have the cursor, that little block there, which is kind of running right now. And so this is customizable, but this actually tells you a lot about what's happening right now in this terminal window that we see open. So the first number you see is this MP32942. That's like the name of your computer. It's called the hostname. And that just basically helps you to identify like what computer you're using right now. It's no different than in the top right or the top left, you have that name that is like the user you've logged in. And that's actually shown here at the right is kind of the username that you're running as, the person that you've logged in as. And you'll notice the colon, which is interesting. And that colon is actually telling you what directory you're in right now. So unlike with, like you say you open Firefox or Chrome or Safari, you almost go to that file open window to like open up a file, or if you go to like Finder, can select an application that you want to use. PowerPoint, Word, it's like you have that file open dialog and you have a bunch of files that you can select. But the difference here is that the application itself, like the shell itself, the thing that you're seeing right here, has a notion of what folder it's in. And so that folder can actually change so that when you do that file open dialog, you don't have to click through every time to get to the right folder you want. You can actually just automatically open things up in that folder without having to click through all of those folder menus to get to the file that you want. And so you'll notice here you have this little prompt that helps us. I'm projecting an on-screen keyboard so that if you're curious, you'll see the characters that I actually press. So if I do this, you'll notice that that enter key is what's being pressed. And so this is the first thing that we're going to cover is that, when you press enter, what it does is it just like prints a new line. And so if I just press enter, nothing really happens, it just basically repeats the prompt. But what I can do is I can clear the screen using Ctrl and then L and start again. And the idea is you can type a command here of some sort. So the first command that we're going to learn is called SLIS. And so as I mentioned before, you have like a directory that the shell is in right now. And so within that folder, of course, there are files that you can see. And so what ls does is it will just print out the list of all the files that exist in this current directory. So if I do that, what you'll see is you'll have these folders here. So desktop, downloads, library, movies, pictures, that sort of thing. And this corresponds to, in Finder, if you look here, if we say code, it corresponds to what you see here in terms of these folders, desktop, documents, downloads, and that sort of thing. And so if we were to go into a particular directory, I mentioned that the directory can change. What you can do is you can use the cd command. And so the cd command is this. And what it does is it'll change what that little squiggly line here is telling you right now. So that squiggly line right now, that tilde, is right now telling you that it's shorthand for a home directory. And so the home directory is like the default directory that the shell starts in. That is just for defaults, just so that you can have a single place that you start out at. What we're going to do is we're going to change the home directory to a new directory. So we go into documents here. So we cd and then documents here. And so what you'll notice what I just did was if I just type in doc, it'll actually, if I press the tab key, it'll actually autocomplete that kind of file name that you saw there. And that's actually super useful so that you don't actually have to type out a lot of the commands. A lot of the times when I'm like going really fast trying to like do something, I just like jam and spam like tab like forever until I find the thing that I want. It actually saves a lot of time so that you don't have to type everything that you want. And so if you cd here, the other thing is if I just try to cd into D, what it'll do is it actually tell me that there are multiple choices for like completion. And so if I press tab here, what will happen is that it'll give you a list of options for things that you want to cd into. So if I press O here, you'll notice that this thing follows the same logic where I've now narrowed down the search of things for potential like completions to those two entries. And so once I press C and then I press tab, what it'll do is it'll automatically complete that for you so that you don't have to type out that string. And it's actually super useful because it just saves you a bunch of time, because a lot of times with long file names, you don't really ever want to type the whole thing out. So I did cd documents, and now I'm going to press enter again. So the idea is that every line that you have, you basically type out a command that you want to run. And then once you're done with that command, you press enter. And what will happen is that that command will run, it'll finish, and then it'll return you to the next prompt so that you can run the next program. So now we're in documents. And so I'm going to clear the screen again using Control and then L. And that allows you a quick little shortcut there to do that. So now I'm in the Documents folder. And so you're wondering now, just to review, we've had ls, so ls, and then I'm pressing enter here. And then we're doing cd here, and then we're pressing enter to get into that directory that we want. So you're wondering, what can I do here? Right now, I'm just like navigating a folder, like how is this different from Finder? The answer is, what we can do is enter text into a file. So what we're going to do is we're going to open up an editor of some sort. So here, all right. So we're going to do basically this. So there's a command called cat. And what cat does is it basically just takes the input that is passed in and basically just prints it out as it entered into the output. And so you might be wondering, well, what are you talking about by input and what are you talking about by output? And the idea is that with like a shell, you have a default kind of idea of like an input. It's called standard input. And the idea is that you can feed data, you can feed information to that program, and it'll output it on what's called standard output. And so what we're going to do here is we're going to use this redirection thing, which is this right, what's it called again? Right caret? I forgot what it's called. Right, anyway, angle, right angle. No, anyway. So we're going to use this character, whatever it's called. And we're actually going to basically take whatever happens with the cat command, whatever output that produces, and we're going to write it to this output file called example.txt. And so this file name that you see here is going to be the name that you'll see this in Finder once we run through the example, is the output that's going to be presented to you. So I'm going to run this, and so what's going to happen when I press enter is that it'll actually give me a blank line. And so just as like a general like helpful tip, if you're ever stuck in a shell and you don't know what to do, your best bet is to use Ctrl C, and Ctrl C will actually help you cancel out of any program that you want. So right now, it's like, oh, well, what's happening right now? If I didn't know how this worked, I'd be like, well, help me get me back to a prompt. And the way you do that is you can use Ctrl C. So hopefully you can see that in the off-screen keyboard, but it's you all know. So like Ctrl C, like Ctrl C here. What's going to happen is that you close out of that program. It'll basically stop the program, stop whatever it's doing, and return you back to the prompt, which is super useful in case you ever like run into any trouble with anything. The other thing that you can do is that I'm going to run this example again. I'm going to press enter. So you're in the same thing here, where you're like, okay, well, I don't want to cancel out of this program, but I do want to like pause it for a moment. And what you can do here is you can actually suspend the running program. Just basically pause it, almost like freeze it, so that whatever it's doing, it just like stops for a moment. And you can do that using Ctrl Z. And it'll show on the screen too, that you'll see Ctrl Z here. And so it's just like useful if you have, say, a long running program, or you realize that you want to like, you know, pause something and just, you know, do something quick and you know, look something up and then come back to this and rerun the program. So right now what's happening is that this cat command right now was running, and now we've stopped it. And so what we can do to resume it is, you'll look here, there's this command called jobs. And what jobs does is it'll tell you what commands are running or paused or stopped. And so if we press jobs here, you'll notice that it gives us this output here, which is that this particular job, which is job 1, is this command that we're running. And right now it's stopped. And so what you can do to resume this job is there's a command called FG, which stands for foreground, which is to say that when you press Ctrl Z and you stopped it, you put the program into the background, in that it's not actively taking up like a terminal prompt, essentially. And so we're going to run foreground now, and if we do that, when we press enter, well, anyway, it's supposed, I mean, if I do, yeah, anyway, it's supposed to basically rerun it. This is just like details. Anyway, let's go back to this example here, example.txt. And so we have this here. If we run it, you'll notice right now it looks like it's hanging, right? And which is like kind of, you know, seems intimidating. But what's happening is that it's actually waiting for you to enter things into your standard input. And so what we can do is we can just basically start typing like lines here. So if I do line 1 here, and I press enter, and I do line 2, and line 3, you just keep on going. And what this is doing is it's feeding that text that you see there into cat. And then what it's doing is that it's outputting that line 1, line 2, line 3 to example.txt. And so you're wondering now probably, well, how do I get out of this? Like I have, you know, I'm pressing enter, and that's normally how I, you know, exit out of the program. Or that's normally how I run a program and get a new line, a new prompt to run another command. So what you need to do is, there's this shortcut called Ctrl D. So it's Control key and then D. What that indicates to the program is that I've reached so-called end of file. And what that really means is that I'm done entering data into that input here. And so that whatever you see here, like these lines here, is all I want to enter. And I'm done here, so I'm going to press Control D and say that it's end of file, so that the cat program knows that we're done with entering text into that program. And so what happens when I press Control D is that it basically takes all of this information, this line 1, line 2, line 3, and a bunch of enters, and it basically just prints it out to standard output. And so that standard output, as we've established, is actually being fed and wired into example.txt. And so if we open up example.txt now, what we can do is cat also gives you the ability to look at that file here. So if I run cat and the name of the file, which in this case is example.txt, it will actually print that to the output here. So you'll see here exactly what you saw in the line above is printed out again here. And that is the simplest example that we could go to, because cat is basically doing nothing else besides basically taking what you put in and just repeating it. It's like the telephone, you know, that never fails. It just kind of like, you know, gives you, basically echoes out whatever you see here. And so just to take a sec to say, well, okay, like this isn't a shell. Well, normally I'm used to having like my documents only be, you know, specific to like Chrome or Firefox or Word. But what you can do is you can actually look at this example.txt and you can find it in Finder. So if you go to this documents folder, you'll notice now that the same file actually exists, not just in the shell, but in this file system here as example.txt. And if we open that up with text editor, you'll notice that it's the same content as what we saw with the cat example. And so say I wanted to change some lines here, do something like this. If I save it, and I close out of this text pad editor, like that. If I go back, you'll notice this file's still here in Documents. If you go back here, you'll notice the shell is also in that Documents folder. But if I cat example.txt, you'll notice that gets updated here. So we've done our first example of how to use the shell and how to create a file using that, using the shell. And so you notice, before I continue, you're like, okay, this is a cool example. I want to do the thing that I just did again, because that was really cool. I want to try to see what I did. And so what the shell allows you to do is have a history of things. And so it's actually a command. So if you run history here, and then you press enter, you'll notice that you'll get all of the things that you've run that you've run, with this example here. And so it lists the things out in the order that you ran them in. And what you can do is, you don't have to actually copy and paste what you see here, although you're perfectly free to. What you can do is you can either use the arrow keys, like up, down, up. Can you see that? Like, yeah, so you'll notice the up key is going down. And you can actually like cycle through all of the different commands that you've run. And so that's kind of cool, because sometimes you'll have a long command where you have like a specific file name that you want that you need to like remember. And so the history helps you out there, because you can just press up arrow and recall that command. The other thing that you can do, glossing over details a bit, but with most command lines that you'll encounter, what you can also do is recall a specific command. So in this case, say we wanted to rerun that cat example. Say I wanted to like rerun this line here for cat. What you can do is you can do exclamation point. You basically type in the exclamation point, and then you type in the number of the command that is listed on the left. And so if I do that, it'll tell me that, oh, okay, I'm rerunning this command again. And so you can basically go through the same process where we'll just do, say, line 1, line 2, line 3, and line 4. So press enter, and then, as you remember, just press Ctrl D to say that I'm done entering data into you, and we'll exit out. And so if we run this command, if we run cat again, if we open up that example.txt again, when you press cat like that, it'll basically update the file, the output that you see here. So before we just had line 1, line 2, line 3. When you run cat and with this symbol, what it'll do is actually overwrite whatever's in that file. And so now you're wondering, what do I want to do if I want to keep what's already there and I just want to like add stuff? And the answer is that you don't just have the one symbol line. What you can do is that you can also add a second of those characters, and what this will do now is append to example.txt. So if we run this and say we do line 5 and line 6, and then I press Ctrl D again, when I cat example.txt, you'll notice that it's been appended like that. So that's the useful thing that you have here. There's cat, and then these two things tell you that you want to append as opposed to outputting and overwriting what you have in example.txt. So we're actually going to evolve this example a bit more, because there's more to the rabbit hole. Say we wanted to so there's an alternate way to do this, and it's especially useful if you're writing a script of some sort. But if we run, we can actually chain these together. So you have this example.txt that you're writing here. And we're basically, what this is saying, if I were to run this, is that I'm going to take whatever I'm like inputting in and just copy it to example.txt. But what we can do is, if we do this, what will happen is that you reverse the direction of the arrow. So what that means is that you're taking the content from example.txt and you're piping it into the input of cat. And then cat will do its thing, which is just to basically parrot out whatever it was sent in. And so if we run this, it's actually identical to what we ran before, where it'll just output that example.txt. Where this gets interesting is if we want to use stuff that isn't cat. So, as an example, we have line 1, line 2, line 3, line 4, line 5. It's kind of a contrived example, but say we wanted to get all the lines that contain the word, the character 4 in them. And so, what we can do here is use what's called the grep command. And so, there's a whole bunch of things you can do with that, with things that are called regular expressions, for now we're just looking for the text, which is 4. And just for the sake of the example, we're going to pipe that into example.text. So what's happening here is that you have the contents of this file. And what's happening is that the shell is basically taking those contents and feeding them into the command that you see here for you. And so that it feeds it into grep. What grep does is it basically looks at each line in the text file and just checks to see if that line contains the character that we're searching for, which is 4. And if it does, print out that line. If it doesn't, don't print out that line. And so this is basically how you find kind of like a Control F in like a shell, is that if you have a text file, and you need a text file of some sort, that includes like HTML, XML, other stuff, the Control F equivalent is what's called grep. And so it'll basically print out the lines that contain that particular pattern. And so if I run this, you'll notice that it's just line 4 that gets placed here. And so for the case of this example, we actually wouldn't do this. There's actually a shorthand for this, where the grep command, if you just take out this, by default, it'll do the same thing for you, where it's just the grep command, you have the command name, and then you press a space, and then you have a pattern, and then you press a space, and then after that, you can have a file name that you want to search for. Yeah. So the idea is that we talked about grep, or commands like this. You notice that includes space and space. And so what's happening here is that you have that first item is called the command, and after that are what are called arguments. And so you press, this would be considered the first argument, and then this would be considered the second argument. And the way you separate arguments is by spaces. So in like more complicated examples, it'll refer to having like multiple arguments. So that's what we're talking about when we're looking at how these commands are like formed. I'm going to pause for a quick second, and does anybody have any questions so far in terms of stuff that doesn't feel clear?
What did the FG
Oh, the FG?
do again?
Yeah. So let me give you an example. So I'm going to press Ctrl L, clear the screen again. So say I have a command like cat. So what's happening here is that cat's just basically waiting for it to tell somebody, it's waiting for somebody to tell it what to do so that it can print it out. So right now it's just kind of hanging. It'll basically keep on going forever until you stop it. With FG, what's happening is that I'm going to basically stop the program here. So if I do Ctrl Z, right now the program's stopped. And so what FG does is it basically allows you to rerun the program again. Yeah, once it stops. And if you do that, that's just it's supposed to basically allow you to resume the program, and what you see here is shouldn't happen, but for whatever reason it's happening right now. So yeah, that's. But what you should be able to do is that when you run FG, you'll be able to basically continue an example that you see here, which is to just echo stuff out to your prompt. Does anybody have any more questions? Anything that?
What do you use this for?
Yeah, so what you'd use this for is if you were like, you have a bunch of files, right? And so it's no different than if you're like opening up in Word. You can use this shell, like there's something called like Vim, where you can actually like open it up, no different than like Microsoft Word. If you do that, you can actually just like run whatever programs you want here. And the other examples are mostly just in terms of basically like manipulating files. If you want to run like simulations, that sort of thing, that's another option. But generally what it's doing is it's just providing you a way to run whatever programs you want. So like no different than like if you're running Firefox or Word, it's like you're using those programs for something. But what the shell is doing is it's just providing another interface or like another way to interact with certain programs. And there are a bunch of different programs. I mean, you can like download documents, you can, a lot of stuff if you're like running code of some sort, you'll generally use this to run commands to compile the code, edit the code, yeah, just to like download web documents as I mentioned, yeah, it's more of just like if you happen to run into this, it's just good to know this. A lot of the days now you can do everything in the browser, but for some of the more technical stuff, this is often what gets used instead because it's simpler and easier to work with as a programmer, not necessarily as a user.
So does it work when, creating HTML, CSS?
Yes.
CSS?
Yes, and with that, what you'd do is you'd use a text editor. So Vim is an example of that, and there's stuff you can do with Vim. Generally, it's easier to use what's called Nano. And this example.txt, if you wanted to like create HTML stuff, you could basically just do that inside this text editor. As an example, say we want to, so as an example, very apropos to a lot of people in SLIS or like, archives, you'll notice that there's an XML. Open up, you can also edit XML, so if you do that, for example, XML, just random tags like, and then say we just did something like that, or we forgot to close our A bracket, that. If I exit out, Control X, and then save modified over here, save that there, and write that out. You can use a command like XML-Lin to actually catch these sorts of errors. Using XML-Lin as an example of XML. You'll notice that it'll tell you that this is not well-formed XML. It'll basically complain that you have end of data in a tag and 1, 1. So we open up the XML, example of XML. All we have to do is just close that bracket, exit out. And so, and so that's just an example of stuff where everything that you can do with like a text editor gets broken down into individual programs on the shell that you can use separately, as opposed to just using a single editor for that. There are a bunch of different examples. I'm actually curious to see if there's stuff in particular that you're interested in using the shell for, or just in general, particular things that you're interested in doing with the shell. And if not, we can just continue on with like other examples as well. I'm not particular in that respect. So we had grep here, and we looked at example.txt. So we have something like this. And so you'll notice this line is something like this. And say we want to like edit the file that we see here. What we can do is we can use a program called sed for that. And so what sed does is that if you look at grep, all it's doing is it's just basically searching for a particular pattern and then just outputting the lines that match. What you can do with sed is you can actually find and replace on each line. So say we wanted to turn line 1, line 2, line 3, line 4, line 5, line 6 to say we wanted to turn that into like an asterisk, just to like format it into like a kind of a pretty list of numbers of some sort. What we can do is we can use sed, and the syntax that we use is that first argument. You can basically search. What this S is saying is it's searching for something, and what we're going to do is we're going to search per line, and then we're going to replace it with an asterisk. And then we're going to complete the command by running it like this. So we'll pass in the name of the file as as the input, and then you'll notice now that you can actually just find and replace like that. And so what's happening here is that it's just basically being printed out to console. And so the tricky thing is here, if you want to just like find or replace in a particular file, what I'm going to do is say I want to do something like this, where I like use the same file. What's going to happen if I run this is that example.txt is going to be empty now. And that's just like a small detail that you'll have to remember, but the thing that you want to do instead, if I populate example.txt, and then I'm going to just basically is if you ever want to like find and replace in a file, like a text file of some sort, and you want to change that in the same file, you can pass what's called like a flag to the command, which allows it to do something slightly different. And so what it's doing here is that if I pass in the -I flag, it's basically going to say that I'm going to take this file, replace some stuff in it, and then just like edit this file in place. And so you notice that a lot of commands, not just sed, have these flags that are available to basically just influence what sort of things that the command actually does. And those options tend to get very detailed very quickly, but in this particular case, if you use sed-I, what it'll do is it'll edit in place. So if we run this, cool. Okay. Scratch that. Okay. Just an example. If we were to continue with this as an example, you have something like this. What you do is that right now you have example.txt here. And what we're doing is we're replacing it to something like this. If you run this and you output it to a new file, let's call it like example1.txt. So you're basically taking output and putting it into example1.txt. You run that, and then you notice now example1.txt has the stuff that you see here. And so what we can do is that we can actually rename that file onto that file. And so what you do is you use what's called the mv command. So what mv does is it combines renaming and Yeah, so it's basically you rename a file to whatever you want. And so the first argument is the file as it's currently named. So let's say like example1.txt. And what we're going to do is we're going to rename that and overwrite whatever's in example.txt. And the other thing that you can do is that if you're unsure of a command, you want to like look it up. What you can do is you can append this pound sign here. And what this pound sign does is it basically turns whatever line you see here into a comment. And what that means is that you can save it, but it won't actually run it if you put a colon in front of the command that you see here. So what it can do is that if I press a comment, if I create a comment here, and I press enter, here, you'll notice in history now, I have that, and I can actually recall it using this and go to beginning file. And if I remove the comment now, I can just use whatever command that I'm running right now. So this is helpful if you want to save a command that you're trying to create, but you realize, as I'm going to do now, that I'm going to double check the contents of example1 and example.txt before I overwrite it. Example1, let's see, you notice that example1.txt is this is our input, and then here, you'll notice that this is what example.txt looks like. And so now, what you're going to see when you run this is that if you do mv example1.txt, it's the first thing that you see there is the old name of the file, and then on the second argument, you see what it's going to be renamed to. So if I run this, what you'll notice now if I press ls is there's just this example.txt. There's no example1 anymore. You just renamed it to example.txt. And if we open up example.txt, you'll notice now that it has the contents. So in addition to renaming, what you can do also is copy files, and that's using the cp command. So say we want to copy the contents of example.txt to a new file name. What we do is we say, it's the same deal where the first argument is just telling you what the original file that you're using, what it's called, and then the second argument is what the copy is going to be called. And you have to spell that out. It's not like when you control Apple C and Apple V, and it just creates a new file name like copy of. You just specify the name here. So I do that, I run ls, and you have this example here, which now if you look, txt, have this, 2.txt here. And so now you're asking, well, okay, how do I check to make sure that these two files are different, or the same? And that's using a program called diff. So say we look at, say, example 2.txt. If we open that up in a text editor, and I'll use Nano here, I'll delete this line here, and then I'm going to press Ctrl X, which is what you see at the bottom left corner. Ctrl X, and then it'll give me this little command here, and then you'll notice here that the stuff in black that you see here are the different things you can press on your keyboard in order to continue on. So in this case, I'm going to press Y to save this file. So I do that, and then here I'm just going to press Enter to confirm that that's the file name that I want to save it under. If I do that, if I do diff, what you do is you have example.txt here, you have example2.txt here. You do that, run this command, press Enter. It'll actually tell me that the file on the left has a line that the file on the right doesn't have, which is that for thing that we just deleted. And so that's super useful if you want to just check to see if the contents of whatever's happening are different or not. It'll basically tell you what line it is, which is what you're seeing here, and it'll tell you the contents of what are different. So that's example 1, example 2, and
Can you only do that for 2 different files? Can you do more than 2?
let me check. So that's a good question. So like, say you have a question like that, where you're like, okay, I want to see how many different ways I can run a command. What you can do are, if you're looking for help, you can use what are called man pages to find that out. So the command is just called man. And then when you open up, and then the next argument to that command is the command you want to look stuff up for. And in this particular case, it's diff. So if you press that as, if you specify that as the argument, press enter, and it'll bring you up to something like this. So what it looks like here is that, just judging by the synopsis, which is telling you all the different ways to do that, there is in fact a way to diff multiple files. And I forgot the exact thing of what it looks like, but from consulting the man page, you can actually do multiple files. So while we're here, we'll run the multiple file diff in a moment, but just to give you a sense that if you're ever stuck, if you're ever curious about a particular command, you can do a man and then the command name, and it'll tell you basically what you can do with that command. It'll also tell you the arguments here, so we have like ignore case, ignore file names, all these sorts of different arguments. But most of the time, what you want to look at is the synopsis to just get a general sense of how you want to use the program. And then if you're looking for a particular flag, you can also scroll down the description. The thing you'll notice here is that we're in what's called a pager. So this is like a special kind of interface. And so to scroll up and down on this man page, what you can do is you can press space and then B. And those are the 2 things. You can also use the arrow keys as well, and page up and page down. So the idea is that you're in a pager right now, so to go through all the different pages in the manual, you can basically use the up and down keys to scroll through that man page. So what I'm going to do is page down. You'll notice these tend to be kind of long, and most of the time what you'll want to do is search for a particular string. What you can do is, if I just press the slash here, what you can do is that you can search in this, if you prefix it with a slash, and then you say search for files that we're talking about. You'll notice, say, in the synopsis here, you'll look at that, you'll see that files is highlighted. And then to go to the next entry, what you do is you press the N key, and it'll basically scroll through all the different ones, all the different matches that you see in the search. So you notice here that we get an additional clarifying information for files in terms of telling us what it means when you specify multiple files. And so, so that's actually more complicated. So actually for diff, you don't, for the way we're using it, you can only use it for like 2 different files. If we try to use it for more than 1 file, it'll actually, in all likelihood, complain. Yeah. So for now, like diff is just 2 files. If you use vim diff, you can actually do more than 1, but that requires you to learn vim. But just to show you, this is what it would look like. Is you can actually get something like this where it scrolls line by line. Here. So you'll notice that all the stuff is kind of highlighted and just takes it out of that. So for the basic diff, yeah, it's just you have only 2 files that you use. So covered man pages, and I think the final thing that I wanted to get to, or actually I think we're out of time, so I guess, does anybody have any more questions that you're curious about? What we've covered today is just generally how to use the shell, creating a text file using the shell, and looking at directories, and how to copy and rename files. And so there's a lot more that you can get into, and I encourage you all, if you're curious, to read the man pages, which will tell you a lot more about what you can do with the system. And to do a man page, all you have to do is type in man and then the name of the